Hello, here in this video we're going to look at 3.2, solving quadratic equations by graphing. Here's the why. Interpreting graphs and tables will enhance your science, business, and social studies skills. Being able to look at a table or a graph and identify, like, hey, this type of value represents or means this, can be very helpful in the different conversations and studies that you'll be doing. So, you might be wondering, well, what does it mean to solve a quadratic equation by graphing? Or really, what does it mean to solve by graphing in general? It's like we know how to solve equations. What you do on one side, you do to the other until you get your variable isolated. But solving a graph, well, what does that mean? So the quadratic equation is an equation that has the form ax squared plus bx plus c. We talked about that the other day. That's the standard form. And what we're going to focus on here is making sure that our standard form is equal to 0, which really means all of the different mathematical terms are gathered onto one side of the equation. All right, so here it says roots of a quadratic equation. And it says the solution or solutions of the equation or the zeros of the related quadratic function. So there's some, terminology in there that you might be a little unclear on, depending on, if you had algebra 1 here or not. And it starts to clarify it here in this next line right here. It says the zeros of a quadratic function are the x-intercepts of the graph. I was like, okay, so let's start a little spot over here. So what we're going to be looking at is a variety of terms that all mean the same thing. So I'm going to write here x-intercept. X-intercept is a term we're all familiar with. That's where our curve crosses over the x-axis. There's some other words that are going to be used in this chapter that mean the same thing. When you see the word zeros, that's talking about x-intercepts. When you see the word roots, that's talking about x-intercepts. And then finally, to answer our initial question, all of these guys are known as solutions. So solutions are finding the x-intercepts, which could also be called zeros or roots. So that's what it means to solve by graphing. We will want to find the x-intercepts for the graph. And so we have an example here that's been done for us. It says, example, solve x squared plus 6 minus 6 is equal to 0 by graphing. And recall from the other day, what we do first when graphing quadratics is we find the x-coordinate of our vertex by using negative b over 2a. So they did that and got the equation for the axis of symmetry, which is also the x-coordinate for our vertex, as negative 1/2. All right, then recall, you can find a y-coordinate. Where they found their y-coordinate was they plugged 1/2, negative 1/2 in for x and evaluated. And they're telling us that when they did that, they got negative 6.25. So negative 6.25. Okay. Now, they went ahead and completed other portions of the table here for us as well. They did not follow the advice that I recommend, which is putting the vertex in the middle of the table. But you can still see, out of the values they did pick, we see that symmetry. And so with that in mind, we could extend our table if we wanted to. And so I'm just going to write over this. So if we had a negative 2, we would know that it's going to match with this value right here to give us a negative 4. If I went one further down and did negative 3, its value is going to match right here with the 0. All right, so that way I just kind of overwrote their table with our own data to continue the table. That way the vertex is in the middle and we can see those lines of symmetry. Now, once they plotted the points here, it became very clear where our x-intercepts are. They are right here and right here, when x is equal to 2 and when x is equal to 3. Now, visually, that's how we find them. It says, where do they cross over the x-axis? So the solutions in this case are x are equal to negative 3 and x is equal to a 2. So something that will be important for us is being able to identify x-intercepts from a table. If we're looking at them from a graph, notice that the x-intercepts fall when we're right here on the x-axis. If we're on the x-axis, that means our y value is equal to 0. If you're anywhere on the x-axis, your y is equal to 0. So what that means is if we want to identify x-intercepts from a table, we want to find where y is equal to 0, which is right here. Notice that it points to that same 2 we just saw on the table. Here's another spot. Notice that it points to that same negative 3 that was on the table. So that's essentially the key takeaway from this section, is understanding what they look like visually. It's where we cross the x-axis. How do I identify solutions from a table? It's where the y-coordinate is equal to 0. So let's do an example of our own. And I'll start us off with this first example here. X squared minus 10x plus 21. They already have it equal to 0 for us, so we're good to go on that front. We're now going to either graph this or make a table. In this case, we're going to do both to figure out where our solutions are. Because right now, you might not be able to think about what numbers you would need to plug in for x to make this equal to 0. So as always, whenever we're going to start graphing a quadratic, we need to find the x-coordinate of our vertex, which is negative b over 2a. So in this case for us, our b is a negative 10. Our c is that 21, which we may or may not need because that's our y-intercept. Our a is the invisible 1. So let me clarify that with the eraser here. We don't need the x squared as a. The a is the 1 out in front of the x squared. All right, so as far as our formula goes, it'll be a negative 10 over top of 2 times 1. So our x-coordinate ends up being a positive 5. So I'm going to draw up a table here. And I'm going to place 5 at the center of my table. Now, if I want to find the y-coordinate for my vertex, I'm going to need to go into my function. And everywhere there's an x, I will need to plug in the 5. And when we do this, we get 25 minus 50 plus 21. So that will give me a negative 25 plus the 21 will give me a negative 4. So that's the y-coordinate for our vertex. And we found that by substituting in our x-coordinate of 5 into our function. Okay, so where we move now is we start to fill in other values on the table. And we can do that by simply counting down, so 4 and 3, up to 6 and 7. But recall here that these two are going to match, as well as these two are going to match. So I don't need to pick all 4 of these. I can just pick 2 of them. All right. So I'm going to go ahead and substitute in either 4 or 6. I'm going to choose 4 because it's smaller than 6 to keep my numbers down. And we'll see what we get. So I'm substituting in 4. So we get 16 minus 40 plus 21. So this right here will give us a negative 24 plus the 21 gives us a negative 3. Okay, so we haven't found our x-intercepts yet because we have not found a y value of 0. So now I'll choose either 3 or 7. And once again, I'm going to choose the smaller option, which is 3. So I'm plugging it back into my function. And I'm going to substitute in the 3. So we get 9 minus 30 plus 21. That gives me a negative 21. Negative 21 plus 21 gives me the 0 that we were looking for. So now, when we go to graph this, we now know where our x-intercepts will be. I can plot my vertex first at 5, negative 4. We have coordinate points here and here. And then also, we hit our solutions right there. So, we just solved our quadratic by graphing. We now know the solutions to this. And recall, solutions mean the same thing as x-intercepts, same thing as zeros, same thing as roots. Our solutions are x is equal to 3 and x is equal to 7. We found that by seeing on the graph, that's where it crosses over the x-axis. We see it in the table because that's when our y values are 0. So that's solving by graphing and using a table. We'll see some more on this together as well because there are some cases about what do you do when zeros don't show up in the table? How does that impact things? As well as a special scenario that's going to happen on one of these. But we'll discover that together as a class.